All the water on our planet, including rainwater, contains chemical compounds that scientists call salts. However, not all water tastes salty. We all know that seawater is always salty, while rainwater and water in ponds, lakes, and rivers are not. So, have you ever wondered why there is such a difference? Could it be that someone dropped mountains of salt into the ocean? Let's explore this mystery with nature's code in today's video. Don't forget to subscribe to the channel so you don't miss the next videos about the natural world. Let's do a small experiment to see how salty seawater is. Take a normal glass of filtered water. Of course, you can drink this glass of water deliciously. Now add a little salt to it. You start to feel the saltiness but can still drink a little because the salinity hasn't reached your tolerance level. Now, continue to add a lot of salt, and surely the glass of water is now undrinkable. Your taste buds will strongly protest that this water is too salty to drink. Seawater is similar. Humans cannot drink it. Seawater is completely opposite to the filtered water we use every day. It contains many dissolved compounds inside, and the human body cannot accept it. So, how salty is seawater? Some chemists have estimated that the Earth's oceans contain more than 50 quadrillion tons of dissolved substances. If the salt in seawater could be extracted and brought to the surface, it would create a layer up to 152 meters long, spread evenly across the continents. This height is equivalent to a 40-story building today. Let's try comparing the amount of salt in seawater to the amount of salt in the water at a lake. In 28 liters of seawater, there is about 1 kilogram of salt. Meanwhile, the water in a typical lake contains only about 4.50 grams of various salts. Therefore, mathematically, we can deduce that seawater is about 220 times saltier than fresh water in a lake. The above has sparked the curiosity of scientists. Why does fresh water in rivers and streams taste salty when it flows into the sea? So, where did the ocean and the salt it contains come from? How can we explain the origin of the enormous amounts of chemical components in seawater? All of this and other related questions are being sought after by scientists. The oceans and seas on our planet include the North and South Pacific Ocean, the North and South Atlantic Ocean, the Indian Ocean, the Arctic Ocean, and the Southern Ocean. Based on ancient marine fossils found on the seabed, scientists have predicted that the ocean is about 500 million years old. So far, there are still many hypotheses explaining the origin of the ocean. However, no hypothesis can fully explain all aspects of the issue. Many studies on Earth agree with the hypothesis that both the atmosphere and the oceans were gradually accumulated from the time of geological formation through the degassing process of the Earth. According to this theory, the oceans originated from water vapor and other gases released from the Earth's molten magma, which then rose high and cooled into clouds covering the surface. After the Earth's surface cooled below the boiling point of water, rain began to fall and continued to fall for many centuries. After all the water fell, it covered almost the entire surface of the Earth, and the first primordial ocean was born. At the same time, the water was also held by gravity, so it did not fall out of the Earth. The origin of salt. Seawater is a complex mixture of mineral salts and compounds from decomposed marine organisms. Most of the mineral salts in the ocean have accumulated gradually. This is the result of the cooling processes on the Earth's crust by weathering and erosion. When mountains were formed, rainwater and streams carried minerals from the land to the sea and gradually accumulated into the large amount we see today. Some salts in the ocean also originate from rocks and sediments beneath the seabed. Another source of ocean salt is from solids and gases released from the Earth's crust through volcanoes. Volcanoes bring compounds from inside the Earth to the outside and accumulate them in the ocean. If fresh water flows into the sea, why is seawater still salty? The amount of fresh water from the Amazon, Mississippi, and Mekong rivers flows into the Pacific Ocean, the Atlantic Ocean, and all seawater is salty day and night. Why doesn't the fresh water dilute the water in the ocean? The reason for the ocean's salinity is the result of many natural processes. The amount of salt inside the ocean is just one of the factors that create this salinity. In the beginning, the ancient sea contained only a small amount of salt and had not yet reached the salinity it has today. But after the first rains poured down on the young Earth hundreds of millions of years ago, the water broke down geological layers and transported minerals to the sea. Since then, the ocean has gradually become saltier. It is estimated that the rivers and streams from the United States that flow into the sea annually carry 225 million tons of dissolved solids and 523 million tons of sediment to supply the ocean. 1. Thus, the amount of salt entering the ocean in dissolved form and leaving the ocean in the form of sediment still does not explain the origin of the seawater's salinity. We all know that salt always concentrates in the sea and cannot move with water vapor. When the sun transmits heat to the sea surface, almost pure water vapor rises high, but the mineral salts remain in the sea. This process is part of the continuous cycle that takes place between the Earth and the atmosphere, the water cycle. Water vapor rises from the surface of the ocean and is carried elsewhere by the wind. When the water vapor meets colder air masses at higher altitudes, it condenses, changing from a gaseous state to a liquid state and falling to the ground as rain. Rain on land is collected by rivers, streams, and eventually flows back into the sea. And the cycle continues. That is why the water in the rivers on land does not taste salty. But when it flows into the sea, it continues to dissolve the amount of salt that is still in the sea and continues to taste salty. In fact, since the first rains fell, the sea has gradually become saltier. The cause of the salinity of seawater originates from the gradual accumulation of eroded compounds on the Earth's crust that flow into the sea. Solids and gases released from volcanoes on land are also carried by the wind to the ocean. Compounds released from sedimentary layers beneath the ocean floor also contribute to the current salinity of seawater. The salinity of seawater can increase or decrease depending on the sea surface temperature, rainfall, and the geographical location of that sea area, whether it receives a large amount of fresh water or not. Seawater is not only saltier than river water, but the composition and ratio of the dissolved salts inside are also different. NaCl, table salt, contains 85% of the dissolved solids in seawater. This is the main reason for the characteristic salinity of seawater. The above is a summary of the reasons explaining why seawater has its current salty taste, from tiny raindrops to silent rivers and vast oceans. All have come together to create something seemingly simple, the salty taste of seawater. It is not just the flavor of salt, but also the trace of time, of the Earth's constant movement. Nature always holds wonders. We just need to stop and explore. Thank you for joining today's journey of discovery. If you found it interesting, don't forget to like, share, and subscribe to the channel to continue exploring the wonderful secrets of the world around us.